Parallelograms, Theorem 1. We have been speaking about parallelograms, which are quadrilaterals that have a different unique properties. We said that parallelograms have opposite sides that are parallel, opposite sides that are equal, opposite angles that are equal, and diagonals, which go from corner to corner, that bisect. Theorem 1 states that the opposite sides and angles of a parallelogram are equal. So, we're going to ask you in grade 10 to prove some theorems. When we're proving a theorem, we cannot assume that this part is true. So, we have to prove it is true. The only thing we know when we're doing parallelograms is that we're given a quadrilateral, A, B, C, D, that has parallel sides, or opposite sides that are parallel. So it definitely is a parallelogram because opposite sides are parallel, but we want to prove the properties. And the properties that we want to prove is, in this theorem, is that opposite sides of a parallelogram are equal and opposite angles of a parallelogram are equal. So if we're given this parallelogram A, B, C, D, if we want to prove that opposite sides are equal, what will we be required to prove? Can you see from this quadrilateral A, B, C, D, to prove that opposite sides are equal, we have to prove that side AB is equal to side CD. And we have to prove that side AD is equal to side BC. If we prove that, we will be able to say, yes, that property of a parallelogram does indeed exist. In order to prove that opposite angles are equal, can you see that we would be required to prove that angle A and angle C are equal? And we have to prove that angle B and angle D are equal. So, we need to prove this theorem. When we're proving theorems, I always think of it like when you had NS last year in grade 9. The theorem is kind of like the hypothesis. Remember, the hypothesis is a statement that you're going to state, and then you're going to prove whether it is true or false by carrying out an experiment. So, this is our hypothesis. We call it a theorem in maths, that the opposite sides and angles of a parallelogram are equal. How are we going to prove that this is true? We're going to carry out an experiment that is going to prove the opposite sides are equal, AB is equal to CD and AD is equal to BC. And we're going to carry out an experiment that is going to show that the opposite angles are equal. Angle A is equal to angle C and angle B is equal to angle D. And now in maths, we don't physically use chemicals in experiments, but we're going to use geometry and our knowledge of geometry to prove with a statement and reason table that this is definitely true in a quadrilateral that has opposite sides that are parallel. In other words, in a parallelogram, we're going to prove this property. So I want you to copy that down. Remember, the heading is Parallelograms Theorem 1. Theorem 1 states the opposite sides and angles of a parallelogram are equal. I want you to draw the parallelogram showing the parallel sides, and then I want you to write down here, required to prove. AB is equal to CD, and this, remember, just is referring to the opposite sides that need to be equal. And then angle A is equal to angle C, and angle D is equal to angle B, referring to the opposite angles that are equal. So if you can just copy that down. Then what I want you to do is I want you to pick up a colored pen. Right? Have 2 colored pens with you, please. And we are first going to, what you need to do when we're proving theorems, particularly in grade 10, is you're going to prove congruency. So I hope you did work on your congruency theorems. And I want you to please draw in a color different to the color that you've drawn your parallelogram in, a diagonal. Now remember, a diagonal goes from one corner to the other. So I want you to draw diagonal AC, and then I want you to draw a statement and reason table. So in your writing book, it should look like this. Theorem 1, that states the opposite sides and angles of a parallelogram are equal. You should have drawn your parallelogram and you should have said what you need to prove. Then under your proof, which is like carrying out your experiment, you draw a statement and reason table. You see, there is my diagonal that I said you must please draw from A to C. So what we're going to do is, if I had to quickly go and draw this palm again, In geometry, it's very good to have a heading. Like if you had to go sail out to sea, you need a direction in which you're heading. So if this is what we needed to prove, that opposite sides and opposite angles are equal, and I asked you to draw a diagonal, right? Where are we heading with this? Well, how would we prove that opposite sides are equal? We're going to use congruency. We're going to prove that this triangle, ABCD, is exactly the same as this triangle, ACD. Why would we do that? In proving that these two triangles are equal, we could prove that this line and that line are equal in length because they're exactly the same, these triangles. These triangles are congruent, and that line would be equal in length. Also because the triangles are congruent. What else would it prove? It would also prove that that angle and that angle are equal because we have congruent triangles. So if I can prove that these triangles are congruent to one another, I can say that opposite sides are equal and that angle is equal. So I needed to prove that AB is equal to CD. Do you see we've got that if I prove those triangles are equal? I also needed to prove that AD was equal to BC. We've just said if these two triangles are congruent, that's the same. I also needed to prove that angle B equal to angle D, which is what we've got. But the last thing I needed to prove was angle A is equal to angle C. And that hasn't been proven with these two triangles. So what we're then going to do is, you're going to draw another line in a different color. And we're just going to look then at these red triangles here. And we're going to prove congruency in those red triangles. Because if this triangle and that triangle are exactly the same, we'll know that that angle and that angle are equal. Hence, proving the last thing we were required to prove. Okay, so that's what we need to do. So how do we go about proving congruency? In our parallelogram, ABCD, where the opposite sides are parallel, and we've drawn a diagonal AC. Just very quickly, before we put pen to paper and we do the actual thing, because we don't know Theorem 1 is true, we are proving that opposite sides are equal. We cannot say that AB is equal to CD. Why? Because we are proving it, okay? We haven't proven it. All we know is that opposite sides are parallel. So, very easy. Could you just also label this, these angles that have been split into angle A1, angle A2, angle C1, and angle C2. Right, so we cannot say that opposite sides are equal because we don't know it. We only know that opposite sides are parallel. What do we know? What are the conditions for congruency? Side, angle, angle, side, 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 angle, side, right hypotenuse, side. Remember, not angle, angle, angle. That's a condition of similarity. Now, if I had to look in these two triangles, what is our clue? Our clue are the parallel lines, because with parallel lines, what do we remember? Fun angles. So we can use the Z, that would prove that angle and that angle are equal. We could use the Z going like that, which would prove that angle and that angle are equal. Remember, we cannot say that angle B and angle D are equal because we don't know it yet. We're proving it with the theorem. So we've got two angles. We can't say that these two angles are the same, and anyway that would prove similarity. What is it that we need to prove? We need to find another side. So between these triangles, can you see they've got that side in common? Side, angle, angle, that would prove that those two triangles are congruent. And that's what we're going to go about doing. So here is your writing book, again it's still in book 2, I hope. And we're going to prove that these two triangles are congruent. So, in triangle ABC, that triangle there, and triangle ACD. What do we know? If we have to label this, like I asked you to, I didn't do it on my book yet, sorry. A1 and A2 and C1 and C2. What do we know? Because of the Z that runs like that, we know that angle A1 is equal to angle C2. Alternating angles, parallel lines that we used was AD is parallel to BC. What else do we know? We can use an N shape. So angle A2 is equal to angle C1. Again, it's also alternating angles. And the sides we used were AB is parallel to CD. And then lastly, because we've got angle, angle, we need a side, and the side to prove congruency is going to be AC is equal to AC, because AC is in common. They share the same line. So therefore we can conclude that triangle ABC is congruent to triangle ACD. And what have we proved with the congruency? We have therefore proved, if these two triangles are exactly the same, we have proved that angle B is equal to angle D. So in other words, check, that's been done. We've proved that line AB is equal to line DC. So that one's done. And we also proved that line, and we've also proved that line AD is equal to line BC. That. The last thing we need to prove, is that angle there. And how are we going to do that? You're going to use the second color that's different to your other colors you've used, and you're going to draw the diagonal BD. And now you're almost going to ignore that blue line, and you're going to look in this big red triangle ABD, and you're going to look in the big triangle BCD. So we're then going to say, they like to use the word similarly, which also means likewise. So we can say likewise or similarly. I'm going to use likewise in triangle ABD, the red triangle, and triangle BCD. So just like in the blue triangle, okay, in the red triangle we can also prove that they are congruent. Likewise, we can prove that triangle ABD is congruent to triangle BCD. And again, it would be, if I had to label this, as B1, B2, D1, D2. Again, we would use a Z shape in the red, right? A Z shape, or an N shape and a Z shape. And then we would use the common side. So we'd also have side, angle, angle. I didn't write it down here, my mistake. Why are they congruent? Because of side, angle, angle. And just like that, in the other red triangles, you can also prove that they're congruent through side, angle, angle. And therefore, what can you say? The remaining one is angle A is equal to angle C. So, likewise in triangle ABD and triangle BCD, the two triangles are congruent, just like here the two triangles were congruent. You can go and prove it, but it's a bit unnecessary because it will be exactly the same in the two triangles. The red triangle, you'll also end up with side, angle, angle, and therefore they'd be congruent, and you can conclude the last thing that you needed to prove. So that's theorem 1. Let's run through it again. You're given a quadrilateral that is a parallelogram because you have the parallel sides. You draw one set of diagonals, theorem 1. So I always remember, theorem 1, draw one diagonal to start off with. Prove congruency. Now, if you started congruency with the red triangles rather than the blue triangles, do you think it matters? No, it doesn't. These statements would kind of then just be swapped, and you would have likewise in this triangles instead of likewise in the red triangles. So you choose which triangles you want to prove congruency, and you prove it with side, angle, angle, and then you say likewise, you prove congruence in the other set of triangles, and therefore you can conclude all these things that you needed to prove, we've proved. And therefore you can say, remember, if you carry out an experiment in NS, you had your hypothesis, you had what you needed to prove, you had your proof or your experiment, and then you need your conclusion. Therefore, what were we trying to prove? That opposite sides and angles of a parallelogram are equal. So therefore, you can say opposite sides and angles of PALM, remember PALM stands for parallelogram, equal. And that would be your final statement. Right, you're now going to have a example. And your example is going to look like this. You can also copy it down. Again, when you come back to school, you'll get all these textbooks and workbooks, but we're assuming that you would have worked through these things a little bit. So we're not actually going to look at this much in class. You have this example. It says, in trapezium ABCD. So ABCD is a trapezium. What do I know about a trapezium? One set of sides are parallel. That's all I know. It says AD is parallel to BC. So in other words, that line and that line are parallel. Angle A is 70, which also equals angle D. So angle A and angle D are equal. And EC is equal to CD. So those two lines are equal. What do we have to do? This question says, prove that ABCE is a parallelogram. Now this is important. We are not told it's a parallelogram. We are told that we have to prove it. When we have to prove that something is a parallelogram, in the previous exercise that you did yesterday, we were told the shapes were a parallelogram and therefore we could use the properties of a palm. But here we're not told it's a palm. So we cannot use the properties of a palm. In other words, we cannot use that opposite sides are parallel, we cannot use that opposite sides are equal, or angles are equal, or anything about the diagonals. You're given this, and you need to prove that this shape here is a parallelogram. How do we prove it's a parallelogram? By proving the properties, like we just did in the theorem. We proved that the opposite sides are equal and proving that the opposite angles are equal by using the information we had. So using the information that we have here, we have to prove it's a palm. Now, like I said, you have to have a heading when you do geometry. So we need to remember, we're either going to prove that opposite angles are equal, or we're going to prove that opposite sides are equal. I'm not even going to go near diagonals at this point because there are no diagonals drawn in this picture. So I'm going to either prove that opposite sides are equal or opposite sides are parallel. So I hope first off you're looking at this picture and you see what you're given. There's a triangle there. What's interesting about the triangle? It's an isosceles triangle. So therefore, what can you tell the marker? Everything you see, you need to tell the marker. The more you tell the marker you see, the more marks you're going to get. So I hope you can see that angle E2 is equal to 70 degrees because it's an isosceles triangle. That's not our accepted reason though. Our accepted reason for an isosceles triangle is angles that are opposite the equal sides. And then fill in as you go. So that's 70 degrees. What can you see now? I want to move into the parallelogram. If I want to prove something is a palm, I need to get as much information about the parallelogram as I can. So how can I move this information and relate it into the parallelogram? Well, I can do angles on a straight line. Therefore, angle E1 is equal to 110 degrees because of angles on a straight line. So if this is 110 degrees, what do you notice about 70 and 110? Well, together they give me 180 degrees, so they are supplementary. So if these two give me 180 degrees together, can you see how I can prove, well then this side and this side must be parallel because it makes a U. So because they add up to 180 degrees, this must be a U shape. Hence, this must be parallel. So I'm going to say, therefore, angle A plus angle E1 equals 180 degrees. Therefore, I can conclude that line AB must be parallel to line EC because they make co-interior angles. So, I've got that this line and this line are parallel. What other parallel lines do I have? Well, if AD is parallel to BC, then EAE must also be parallel to BC because this is on a straight line. So, I also have AE being parallel to BC. That information is given to us on the picture. So if I've got two sets of parallel lines, what can I therefore conclude? That ABCE is a palm. Why on earth is it a palm? Well, because we've just proved that opposite sides are parallel. And that is a property of a parallelogram. I've got two pairs of opposite sides that are parallel. This and this are parallel, so therefore the shape is a palm. Now you're going to be expected to do two more like this, where you have given a shape and you have to prove that it is a palm. I'm going to show you what you're given. See? So here we go. I'm going to zoom in a little bit, just bear with me. Right, so this one here, it says, in quadrilateral LMNP. LMNP. So we're told it's a quad. We aren't told it's a palm, so we cannot use the properties of a palm. Okay? They give us a little bit of information. E1 is 62, P1 is 68, P2 is 56, and we're told that line FP is equal to line FN. And we're also told that line LE is equal to line LM. So go and fill that in on the picture, redraw the picture, and then we're asked to prove that lines are parallel. Whenever we need to prove lines are parallel, you have to find the fun angles. So what do I mean? If I give you a shape like this, and I want you to prove, sorry, it doesn't look parallel, but just assume that it is. I have to zoom out. And I ask you to prove that this is A, B, C, D, and I ask you to prove that line AD is parallel to line BC. I have to find the fun angle. So in other words, I either have to find that this angle and this angle are equal, because if those two are equal, what fun angle have I found? I found corresponding angles. Or, for instance, I have to find that this angle and this angle are supplementary, because what fun angle have I found? I found cointerior. So when you are asked to prove that two lines are parallel, you have to go and look at the shape and find a fun angle. And your reason would then be, well, because I can see a cointerior angle or a alternating angle or a corresponding angle, because I can see one of these shapes, they must be, well, because I can see and prove one of these shapes, the lines must therefore be parallel. I hope that makes sense. And then it says, prove that's a parallelogram. Again, I'm giving you a hint. You must only prove opposite sides are parallel, or opposite angles are parallel, or opposite sides are equal in length. Don't even try looking at the diagonals right now, or the last property of a palm that we haven't really even discussed. You're going to prove one of those properties. So you're going to prove that LP and MN and LM and PN are either parallel or equal, or you're going to prove that angle L and angle N are equal, or angle P. Remember, the whole of angle P, not just P1 or P2, and the whole of angle M, not just M1 and M2, are equal. So one of those properties you have to prove. You don't have to prove all of them. And then you're going to be given this. It says AC and DB are diagonals of a quad. Again, we're not told it's a palm, so you cannot use the properties. You can only use what they're given you. So diagonals of a quad with AO being equal to OC and BO being equal to OD. It says prove that these two triangles are congruent, and those two triangles are congruent, and therefore prove that this is a palm. Again, you're either going to prove opposite sides are parallel, opposite sides are equal, or opposite angles are equal. Don't even look into the diagonal thing. Pretend I never even told you about that right now. So you're going to first prove congruency between the certain triangles, and then you're going to prove it's a palm. And I hope you can do that. This is really what it comes down to in grade 10. Taking shapes and proving that there are certain specific quadrilaterals, be it a palm, be it a square, be it a rectangle, be it a kite, whatever it may be. So you really need to concentrate on this. Okay, grade 10s, that's what you're going to do. Thanks.